Dear students, welcome to lecture number 25. Now in lecture number 24 we have designed RCC square column. Now in lecture number 25 we are going to design RCC rectangular column so that we can understand how it is different from RCC square type of column. Now even in this design problem I have taken the problem related to rectangular type of section. And same methodology, that means we have to take into account axially loaded RCC rectangular type of column. Now let us first of all understand that what is the statement of problem statement. So we have to design a rectangular column and which is subjected to an axial load of 2500 kilonewton. So you can see here load is quite high as compared to previous type of problems. So this much load we have to take into consideration and that and live load case. The column is braced against side sway in both directions. So we can say that there will not be any possibility of sway. So accordingly we can design the column. And it is having an unsupported length of 3.5 meter. Now we can assume moderate type of environmental conditions, but however it is suggested that we can use M30 grade of higher grade of concrete that we have selected because load is comparatively higher. So that means either we have to take a higher section as well as we can take a higher grade of concrete also. And steel we will be taking Fe 415. So first of all, again, in step number 1, we are going to discuss that or list what is the grade of concrete and grade of steel. So unsupported length is given, that is 3.5 meters. So given in the numerical itself. Now end condition, if we say, so end condition is not properly specified, but it is given that column is braced against side sway in both direction. So one thing is very much clear that a column will be strengthened from both sides, so it will not be able to fail in any type of buckling type of behavior. It is expected that it will behave as a short column. Now since column is supposed to have moderate type of environmental condition, but still as a problem itself suggests us that we have to take 30 grade of concrete and steel Fe 450 and the nominal cover as usual as per IS 456 guideline we are taking here 40 millimeter. So by adopting M30 grade of concrete and steel of high strength steel, that is Fe 415 grade, and with the clear cover or nominal cover we can say that is 40 millimeter. So all the parameters we have decided in this step, and let us proceed to step number 2. Now in step number 2, again we have to first of all assume the what should be the dimensions of the column. So that dimension is always based on the load, since load is 2500 kilonewton and it is given it is an axial load. So by applying partial safety factor we can easily work out that how much is the effective load. So this is the same methodology as we have discussed in the square type of column. So ultimately we are getting that is a huge load, we can say higher value of the load. So column actual load is quite high, that is 3750 kilometer. Now when we have to take into consideration that we have to decide or assume what should be the longitudinal steel. So that longitudinal steel ratio you are well aware that as per code advice we can take in between 0.8% to 6%. So here since the load is greater we can take a higher percentage of steel. It may be taken as 4%, 5%. So let us take 3% of the steel. That means area of longitudinal steel we are taking 3% of the gross cross section area because load is comparatively higher in this case. So that means we can work out that ASC, that is area of main steel or longitudinal steel, that is equal to 0.003 of a gross area of the section, and then gross area is composed of area of concrete as plus area of the steel. So from this equation we can rearrange, and ultimately we are able to get that area of concrete is equal to 1 minus 0.03 Ag. So that means area of concrete in this section is 97%, or that is 0.97 of gross area of the section. So by using the same formula, because it is a short type of column, which because it is supported from the all sides, so by just assuming that it is a short column, later on we will be going to check whether it comes under the classification of short column or long column. So if it is no, our assumption is not correct, then we can change the design parameters. So here we have to put all the details which are available. So 3750 was the kilonewton by the factored load, and 30 is the grade of concrete which we have taken, and the AC is 0.97 Ag as usual. Now here this is a 0.03 Ag is the steel which we have assumed. So based on this formula, and after going through the calculation, we are able to get gross area. So that means this much gross area is required to take care of 3750 kilonewton load at least. So since we are going to design a rectangular column, so randomly we can choose the section. So by trial and hit and trial, you can just select the size. So I have selected the rectangular column of size 400 millimeter by 500 millimeter. So based on this assumption, so what is the gross area? Gross area which we have provided by providing 400 millimeter by 500 millimeter rectangular column. So this is the gross area which is available. So that means ultimately we have provided gross area 2 lakh millimeter square, which is greater than this much which was required. So here the section chosen is okay, and we can proceed with the next step. Now in step number 3, we have to check, we will apply the check for whether it is a short column or whether it is a long column. So that means we have to classify here. We can refer table number 28 as we have referred in the previous numerical also. Since the column is based on the both sides, so we can take the value that L effective is equal to 1.0 L. So that means the factor we can take 1. And so effective length of column will be 3.5 meter. It was unsupported length, and we have multiplied with a factor 1. So it comes out to be 3.50 meter. So now we have to check the slenderness ratio in both the directions, since you can say that a section which we have chosen like this, maybe 400 by 500. So one will be along x-axis we can say, and another will be along the y-axis we can say. So a slenderness ratio along a shorter size we can say shorter lateral dimension. So that is L effective by V. So it comes out to be 8.75, which is lesser than 12. So we can say here this much slenderness ratio is okay for shorter size of the, or you can say shorter dimension of the cross section of the column. Now let us check for the longer dimension, that is 500, which we have taken. So lambda y is L effective by capital D. So we have taken 0.5. So it comes out to be 7. It is less than 12. So we can conclude that since as per the IS codal provision, both the slenderness ratio are less than 12. So this is a perfect classify as a column which is a short type of column. So here we have concluded that it is a short column. Now step number 4, we have to apply the check for the minimum eccentricity. Again, now as per codal provision we have discussed in the previous 2 lectures, so we are able to calculate, and it comes out to be greater than 20. So that means it's okay, no issue, because we can take 20 as a eccentricity. But let us check the other parameter also. Now EY comes out to be 23.66. So both are greater than 20. So minimum eccentricity as code suggests is 20 mm. So it is a greater than 20 mm. So then it is okay. Now we have to apply the check as per IS 456 guideline. So another guideline is you have to check that is the dimensions of the cross section of the column, multiply it with 0.05. So it comes out to be 20, and in other side it comes out to be 25. So hence we can say that this check for the minimum eccentricity is following the guideline, or is according to the guideline mentioned in IS 456. So we can say it is a short column, and to check the capacity we can use the formula which is given in IS 456 2000. Now in step number 5, we have to calculate what is the longitudinal reinforcement required, and accordingly we have to decide what should be the size of the bars as a longitudinal reinforcement, and how many number of bars we have to provide. So again using the same formula, and putting all the values, this was the size which we have decided. So that is the gross area minus, now it is area of the steel, so it comes out to be area of concrete itself, and similarly ASC. So by solving this particular equation, you can say this is equation A. So by solving this equation, we can easily work out what is the longitudinal steel required, how much area of longitudinal steel is required, which can take this much load, 350 into 10 raised to power 3, that means 3750 kilonewton. So if the section is made up of M30 grade of concrete, and following are the dimensions and how much steel we have to provide, so that this equation is valid, or we can say this section along with steel is able to take this much load which is coming on the section. So solving this equation, we are able to get that this much is the area of steel as a longitudinal steel required, 5074. So it is a quite a higher value of the area of steel, we can say. So now again, as per the check, first of all we have to check what is the minimum steel need to be provided as per IS 456. So it comes out to be 1600 millimeter square, and we require 5074, so definitely it is greater than 1600. Now then maximum steel which we can provide as per a restriction given by IS 456, so that is 6%, and calculation 6% comes out to be 12,000 millimeter square. So since we have to provide area of steel 5074, it is in between these two, so that means we can provide this much area because it obey both the conditions, and these are the limits as recommended, so we can provide it. So what we have decided, let us decide that we will be providing 8 number of bars. So 4 number of bars will be taken of 32 mm dia at the corners. So we will be providing at the corners of the section, 1 bar at each corner. So 4 bar will be required to place at a corner of a greater size. And 4 number of bars of 28 mm dia we will be providing at the middle of the each face. So that means if this is the section, so here you can provide at corner you can provide 32 mm dia, and in between here at the mid of the face you can say, so we can provide these 28 mm dia bars. You have to keep in mind that you have to design the steels in such a way that it should be symmetrically located in the section. So based on the calculation that how much is the area which will be provided by 4 bars of 32 mm and 4 bars, so total area comes out to be 5677 millimeter square. So it is greater than 5074, which was a requirement. So we can say here even this check is okay, we can proceed with the design from up to step number 6. Now in step number 6, as usual, we have to design the transverse reinforcement, and you can refer this subclause, that is 26.5.3.2 part C, and the second part out of that C. So diameter of transverse steel, first of all we have to decide. So as per a codal advice, we will be always following the codal guidelines, and it should not be lesser than 1 and 2. So first is condition is diameter of the largest longitudinal bar. Since we have provided two type of bars, 28 mm and 32 mm, so largest is 32. So it comes out to be 8 mm. And second check is minimum is a 6 mm. So what code is suggesting that when we have to select the transverse reinforcement, that means lateral tiles we have to decide, then the diameter of that lateral tile shall not be lesser than 1 and 2. It should not be lesser than. So what we have decided, let us adopt 8 mm dia lateral ties as a transverse reinforcement. And now we have to decide the pitch, that what should be the center to center spacing between the adjacent transverse reinforcement, that is lateral ties. Again referring the codal guidelines. First of all, condition is the least lateral dimension. Since we have dimensions 400 by 500, so least will be 400 millimeter. And another condition is 16 times diameter of the smallest longitudinal bar. So smallest longitudinal bar is 28. We have decided 28 as well as 32. So both diameter bars we have selected. Least one is 28, so it comes out to be 448 millimeter. And the third condition is the 300 millimeter. So ultimately we have to select the spacing or center to center spacing, which is termed as pitch of the lateral ties. So we can't go beyond 300 millimeters. So what code is suggesting? Code is suggesting that maximum pitch should not be lesser of these three. So condition 300 is need to be satisfied. So ultimately, based on the above criteria, we have decided to provide lateral ties of 8 mm dia at 300 millimeter center to center pitch as a transverse reinforcement. So in this step number 5 and step number 6, we have decided that what should be the longitudinal steel as well as transverse steel. Now last but very important part of the design problem is always the reinforcement detailing. So what we have decided that all the dimensions in the drawing will be in millimeter. Main steel, that is longitudinal steel, is 4 bar of 32 mm dia. We will be providing at corners of the section. And another 4 bars of 28 mm dia we will be providing at the mid of each face of the section. And the lateral ties of 8 mm dia at a spacing of center to center, that is 300 millimeter. So now what is the reinforcement detail of rectangular column? So you can easily understand from this diagram. Now this is the section of the column, that is 500 by 400, and this will be the height of the column accordingly. So what we have provided, these black color bars are indicating that these are the lateral ties which we have provided, and these lateral ties are of 8 mm dia, 300 millimeter center to center. Now here in this diagram you can easily understand that outer black color steel bars, they are of 8 mm dia, 300 millimeter center to center. So we have provided the lateral ties as well as to strengthen and to fix the position of all the reinforcement bars which we have provided at the center of the face of the section. So we have tied them together with a polygonal type of ties. So again we have taken 8 mm dia bars of at a 300 millimeter center to center spacing. Now at each corner we have provided 4 number of bars of 32 mm dia, and at the center of each face we have provided 4 number of bars of 28 mm dia. So this was the completion of this design problem, and you can for practice you can take another similar type of problems, and you can just solve to understand more effectively. If you have any doubt, any clarification you want, then you can ask me on the comment section of the YouTube. Thank you.